Yeah, good evening. We are back with our class on surface chemistry and coordination compounds. Did you get that notebook? Go back. So, we will continue with surface chemistry. We studied yesterday that surface chemistry, basically we are talking about colloids. We are doing surface chemistry from the last part. So, we studied colloids are solutions or substances which have been classified as colloids, true solutions and suspension. True solutions have a particle size between less than 1 nanometer. Colloids have a particle size between 1 nanometer to 1000 nanometer. And anything above 1000 nanometer is called as what? Suspension. Colloid generally means a heterogeneous system where a dispersed phase is dissolved in what medium? Dispersion medium. It has a large surface area. After that we studied classification of colloids. The first classification of colloids was done on the physical nature of the dispersed phase and the dispersion medium. There are how many types of colloids? 8 type of system. But the most common ones are sol, which is solid dissolved in liquid, gel, which is liquid dissolved in solid, and emulsion, which is liquid dissolved in liquid. If the dispersion medium is water, it is called what sol? Aquasol or hydrosol. If the dispersion medium is alcohol, it is called alkosol. If the dispersion medium is benzene, it is called benzosol. The second classification we studied is the affinity of the dispersed phase and the dispersion medium. We said what? If there is high affinity between the dispersed phase and the dispersion medium, it is called as what colloid? Lyophilic colloid. If there is very less affinity between the dispersed phase and the dispersion medium, then it is called as what colloid? Lyophobic colloid. We studied difference between lyophilic, lyophilic and lyophobic colloids. Now today we will study the third classification of colloids. The third classification of colloids is basically based on the type of particles of the dispersed phase. What are the different types of particles of the dispersed phase? So depending on the type of particles of the dispersed phase, we basically classify colloids as multimolecular colloid. Now first bardubiಡ್ತೀನಿ ಆಮೇಲೆ explain ಮಾಡ್ತೀನಿ. Multimolecular colloid, associated colloids and macromolecular colloids. We will classify them as what? Macromolecular colloid and associated colloids. What is the difference between the three types? Now let us understand. We said colloidal particles are having a particle size between 1 nanometer to 1000 nanometer. Okay? So to get this size of particle, many smaller particles of true solutions can arrange themselves in multiple layers to form a colloidal size particle. This kind of layering is called as what? Multimolecular colloid. Chota particle or very small particle, they layer themselves one above the other to form a particle size of the colloids. So it is called as what colloids? Multimolecular colloids. As many molecules line layer by layer to come to colloidal size particles, and hence they are called as what? Multimolecular colloid. What is macromolecular colloid? When the particles of suspension, which is above what? 1000 nanometer, break down into particle size of 1 nanometer to 1000 nanometer, it is called as what? Macromolecular colloid. Understood? When two solutions join together to form particles of colloidal size, multimolecular. If the large macromolecule, such as your proteins, such as your amino acids, such as carbohydrate, break down into colloidal form, then it forms particle of what size? Macromolecular colloids. Now associated colloids. Associated colloids are colloids only after a particular temperature, and that temperature after which it acts as a colloid is called as what temperature? Kraft temperature. And the concentration beyond which it acts as a colloid is called as critical micelle concentration. Am I clear? First thing, multi-molecular colloid, when the particles which are smaller in diameter and size arrange themselves layer by layer to form particles of colloidal size. Macromolecular colloids, when a large particle of suspension or particle size of suspension breaks down into particles of colloidal size, it is called as what colloid? Macromolecular colloids. These associated colloids, they are generally acting as electrolyte at a low temperature, but beyond a certain temperature, they start behaving like a colloid. That temperature beyond which it behaves is called as what? Kraft's temperature, and the concentration beyond which it behaves as a colloid is called as CMC, critical micelle concentration. So we will read this part first. So we have classified three types of colloids. First, on the basis of the nature of dispersed phase and the dispersion medium. Second, on the affinity between the dispersed phase and the dispersion medium. Third, when the nature of particles of the dispersed phase. What are the nature of the particles? Whether they are smaller size, whether they are broken down from the larger side, or whether they are particles of the electrolyte, which beyond a certain temperature behaves like a colloid. The temperature is called as what? Kraft's temperature, and the concentration is called as critical micelle concentration. All three classification clear? Yes or no? Now let us read through it. Depending upon the type of particles of the dispersed phase, colloids are classified as multimolecular, macromolecular and associated colloids. Multimolecular colloids. On dissolution, a large number of atoms or smaller molecules of a substance aggregate together to form species having size in colloidal range. The species thus formed are called as multimolecular colloid. Did I explain Monday? Smaller particles arrange themselves in layer by layer to come to particle size of colloidal particles. This is called as what? Multimolecular colloid. Example, underline muddy, gold sol. Gold sol contain particles of various sizes having many atoms. Second, sulfur sol consists of particles of thousands or more of S8 sulfur particle. So multimolecular colloid example, gold and sulfur sol. Now let us come to what? Macromolecular colloids. Macromolecules in suitable solvent from solutions in which the size of the macromolecules may be in the colloidal range. Such systems are called macromolecular colloids. These colloids are quite stable and resemble true solutions. Examples: starch, cellulose, proteins, enzymes, polythene, nylon, polystyrene and synthetic rubber are all examples of macromolecular colloids. Now associated colloids, very very important, please write there what is CMC and what is Kraft's temperature. How do you represent Kraft's temperature? TK. What is CMC? You can write it in capital as critical micelle concentration. Okay, so let us read through it. Associated colloids or micelle. Underline, very important CET question. What are associated colloids also called as? Associated colloids are also called as micelle. Okay, we have studied micelle in soap. 10th ki aapka idea, micelle formation in soap. Same thing I will repeat today. There are some substances which at low concentration behave as strong electrolyte. So at low concentration, associated colloid behave as strong electrolyte, but at higher concentration, they exhibit colloidal behavior. The aggregated thus particles formed are called micelle. They are also known as associated colloid. They are formed only above a particular temperature, which is called Kraft temperature, and above a particular concentration, which is called as critical micelle concentration. Understood? This was taught that initially they behave at a lower temperature or at a lower concentration. They behave like what electrolyte? Strong electrolyte. But at a higher concentration, they start aggregating themselves and come to the colloidal size. So these aggregates are called as what? Micelles. They are formed beyond a certain temperature, which is called as what temperature? Kraft's temperature, and beyond a certain concentration, which is called as critical micelle concentration. On dilution, these colloids revert back to individual ions. Surface agents such as soap and synthetic detergent belong to this class. So macromolecular colloids, starch, polythene, polystyrene are examples of macromolecular colloid. Multimolecular colloid, gold sol and sulfur sol. Associated colloids, soaps and detergents. Is classification clear? So I will again sum up from the beginning. Although I know you will be sleepy listening to the same thing, but it should come. Chapter nodadre gottagbeku. First thing, colloids are what system? Heterogeneous system. Colloids are heterogeneous system and the dispersed phase is dissolved in dispersion medium. The dispersed phase is small in quantity and the dispersion medium is always large in quantity. And colloidal particles basically have a particle size of 1 nanometer to 1000 nanometer. Below 1 nanometer is true solution and above 1000 nanometer is suspension. Colloidal solutions have a large surface area. Depending on the three factors, we classify colloids. First, depending on the nature of dispersed phase and dispersion medium, we have solid dispersed in solid, solid in liquid, solid in gas, liquid in solid, liquid in liquid, liquid in gas, gas in solid and gas in liquid. Gas in gas becomes a homogeneous system and hence it is not considered as a colloidal system. Then we studied that if the dispersion medium is benzene, it is called benzosol. If the dispersion medium is water, it is called aquasol or hydrosol. If the dispersion medium is alcohol, it is called alkosol. If there is high affinity between the dispersed phase and the dispersion medium, it is called as lyophilic colloid. If there is less affinity or no affinity, it is called as what? Lyophobic colloids. Lyophilic colloids are stable, lyophobic colloids are unstable. Lyophilic colloids are reversible, lyophobic colloids are irreversible. They are reversible means if they become dry due to evaporation, I can add a little of dispersion medium and again it will come back to its original colloidal form. These do not require any special means of preparation, but these require special medium. They do not require to add any stabilizing agent. These require to be added some kind of stabilizing agent. So these are the differences between lyophilic and lyophobic salts. In general, when we are talking about colloidal solution, we generally name it as sol, which means solid dispersed in liquid. Gel, which is liquid dispersed in solid, and emulsion, which is liquid dispersed in liquid. Depending upon the type of particles or the nature of particles of the dispersed phase, we have three types of colloid: multimolecular colloids, macromolecular colloids, and associated colloids. Multimolecular colloids are particles which are smaller in size. They stack themselves one over the other to come to particles of a colloidal size. Example, gold and sulfur salt. Macromolecular colloid, macromolecules such as starch, protein, amino acid, when dissolved in water, come back to particle size of colloids. As a result of it, they are called as what? Macromolecular colloids. Naturally occurring macromolecular colloids, starch, cellulose, proteins, amino acids, etc. Synthetic, polythene, polystyrene, they are examples of synthetic macromolecular colloids. Associated colloids, these are colloids which behave as strong electrolyte at lower concentration, but at higher concentration they tend to behave like, they tend to aggregate themselves and form micelle. The temperature beyond which they act as colloids is called as Kraft temperature, and the concentration beyond which it acts as a colloid is called as critical micelle concentration. Soaps and detergents are example of associated colloids. They are also called as micelle. Clear? Now, the cleansing action of soap, basically till here everything clear? No doubts? Now one more part, the cleansing action I will finish. Then in the next week we will do preparation of colloids. So here we are supposed to talk about micelle formation. Micelle formation basically happens on the surface. Micelle formation, you have studied the cleansing action of soap. Let us talk about the soap such as C17, H35, COONA. This is sodium cearate. Okay, so I have taken a soap which is C17, H35, COONA. The hydrocarbon part of it is represented like a tail, and the ionic part of it is represented like a head. So this is the diagrammatic representation of a soap. The hydrocarbon part of it is represented like a tail, and this part is represented like a head. This tail is what in nature? Lyophobic in nature. And the head is lyophilic in nature. Fine? Is it clear? If you don't want to write lyophobic and all, you can write hydrophobic and hydrophilic, because you are making soap, dissolving soap in what? Water. So the tail is what? Hydrophobic. Whereas the head is what? Hydrophilic. Head loves water, but the tail does not like water. Or it does not like what? It likes oil but does not like water. So the dirt, which is generally on the surface, the cloth surface, this is the dirt. The dirt is always what in nature? Oily in nature. Fine? When this cloth which is dirty is dipped in water and you dissolve the soap and get the micelle on the surface of the soap, these micelle particles basically will arrange themselves radially around the dirt, full all along the circumference. You will find that they will arrange themselves on the surface. These tail parts will break the oil or break the dirt into smaller pieces, and then they will try to take away the dirt. The dirt is pulled now from the cloth, and now it is there in water. So the tail part or the hydrophobic part pulls away the dirt, and the hydrophilic part keeps the dirt suspended in water, and hence the water becomes dirty but the cloth becomes clean. This is how micelle formation takes place, or cleansing action of soap takes place. Soap has a formula something like this. What is soap? It is sodium or potassium salt of long chain carboxylic acid. The hydrocarbon part is represented like a tail, whereas the ionic part is represented like the head. The dirt, which is oily in nature, is pulled by the hydrocarbon part, and the hydrophilic part or the ionic part keeps the dirt suspended in water. So the water becomes dirty but the cloth becomes clean. So when you rinse it multiple times, all the dirt goes and gets suspended in water, and the cloth comes clean. This is called as cleansing action of soap or micelle formation in case of soap. Okay, so now read till preparation of colloids. Pause the video. Now we will start with coordination chemistry from from wherever we left. Let us revise back coordination chemistry. We started with salts. We said salts are product of neutralization reaction. They have one acid radical and one basic radical. They give test of the individual ions when dissolved in water. Example, NaCl last chapter here. Example, NaCl, NaNO3, K2SO4, MgCl2. These are all examples of what salt? Simple salts. Now we have to study next is what? Double salts. What are double salts? When two or more simple salts are present with their water of crystallization. What are the three examples of double salt we learned? Carnallite. What is carnallite? KCl, MgCl2, dot 6H2O. What is potash alum? K2SO4, Al2SO4 thrice, dot 24H2O. Then we studied what? Ferrous ammonium sulfate or Mohs salt. What is Mohs salt? FeSO4, NH4 twice SO4, dot 6H2O. So, these three salts, they are a combination of two or more simple salt, and when dissolved in water, they give a test of their individual ions. The third salt what we study is called as what salt? Complex salts. These are salts when dissolved in water, or when dissolved in any solution, they do not give test of their individual ion. Example, potassium ferrocyanide. How do we write formula potassium ferrocyanide? K4. FK4. What comes? Square brackets. These square brackets are called what sphere? Coordination sphere. And anything which you write within it is called as what? Coordination entity. So K4, FeCN6 is potassium ferrocyanide, which ionizes as what? 4K plus FeCN6 4 minus. So this is a complex ion, and the study of these complex ion constitute coordination chemistry. This is what we studied yesterday. Then we studied what? Important terms in coordination chemistry. First is what? Coordination entity. In a complex ion, there is always a central metal atom surrounded by a number of donor atoms, fixed number of donor atoms or ions, which are called what? Ligands. This is called as what entity? Coordination entity. Anything which is written within the square bracket, which consists of a central metal atom, fixed number of donor atoms, is called as what sphere? Coordination sphere. This is the non-ionizable part of the complex ion. Anything which has to be ionized has to be written outside the square bracket. Then we studied what? Central metal atom or ion. The central metal atom or ion is generally a metal atom belonging to what series? 3D series. 3D series, and it should have a d orbital which is incompletely filled so that it can accommodate all the electrons donated by the ligand. 21. Which element? Scandium. 22. Titanium. 23. Vanadium. 24. Chromium. 25. Manganese. 26. Iron. 27. Cobalt. 28. Nickel. 29. Copper. And 30 is zinc. Initially 21. Then titanium, chromium, iron, manganese, iron, cobalt, nickel, copper, zinc. These are elements of 3D series starting from scandium and ending into zinc. After that, I think we studied coordination number. The fixed number of metal donor atoms or ions surrounding the central metal atom are called as what? Coordination number. If the coordination number is 6, it is what complex? Octahedral complex. If the coordination number is 4, it is tetrahedral complex. write ligands. In your notebook, please write ligands. Write atoms, group of atoms, group of atoms, comma, anions or cations, which donate a pair of electron, to the central metal atom or ion, which donate a pair of electron to the central metal atom or ion, is called ligand. Atoms, group of atoms, cation or anion, which donate a pair of electrons to the central metal atom or ion, is called as a ligand. Next for you. Depending upon the number of electron pairs, the ligand donates, they are classified as, ligands are classified as monodentate or unidentate ligand. I am writing here, please write monodentate or unidentate ligand, bidentate ligand, tridentate ligand, and polydentate ligand. Depending upon the total number of electron pairs that are donated, they are called as what? Monodentate or unidentate ligand, bidentate ligand, tridentate ligand. We studied till hexadentate ligand, but beyond tri, they all come under what? Polydentate ligand. So if the electron pairs donated is 1, unidentate, 2 electrons pair donated by the ligand, bidentate, 3 electrons pair donated, tridentate, more than 3, polydentate ligands. Clear? Now write denticity. What do you mean by the term denticity? Most of the central metal and atom or ion are all what? Lewis acids. Why are they called as Lewis acids? Because they accept the pair of electrons. Please write now denticity. Right? The total number of electrons pair, or write like this, it is the total number of the ligating atoms. It is the total number of ligating atoms. Ligating atoms means ligand atoms that bind to a metal ion or atom, in a coordination entity. It is the total number of ligating atoms that bind to a metal ion or atom in a coordination entity. Fine. Definition of denticity carries 1 mark. It is asked as a 1 mark question. Explain the denticity of a ligand. Okay. So we can also write denticity as the number of electron pair it donates. If it donates one electron pair, it will link to the central metal atom by one bond. So it is called as what dentate ligand? Unidentate ligand. If it donates two, it will be called as bidentate. So if it donates two means two pairs of electrons. Which electrons it is donating? Lone pair electrons. Fine. Now write heading unidentate or monodentate ligands. Unidentate or monodentate ligands. These are ligands which can donate only one pair of electron to the central metal atom or ion, to the central metal atom or ion in a coordination compound, to a central metal atom or ion in a coordination compound. So nothing, no explanation required. Unidentate ligands means they donate only one pair of electron. So write उसमें A करके लिखो negative unidentate ligand. Negative unidentate ligand. Okay. Now what is important about these negative unidentate ligand? Whenever you write the name of these negative unidentate ligand, you need to add an O to it. Did you get my point? All negative ligands ends as O. Like OH minus, what it is? Hydroxide. This will become what? Hydroxo. Clear? What is Cl minus? Chloride. This becomes chlorido. What is Br minus? Bromido. What is I minus? Iodido. Or some people write it as iodo. But according to 1994 convention of IUPAC, it should be written as what? Iodido. Okay. Nishan, nothing I am teaching outside syllabus. It's not there in the textbook. Don't check. Okay. Otherwise, I wouldn't have made you write. Clear? Cn minus? Cyanide. So, cyanido. बताया SO4 2 minus? Sulfato. Is it clear? All negative ligands will end with O. Sulfato, chlorido, bromido, cyanido, iodido. H minus? Hydrido. Okay. H minus is what? Hydrido. Now please write. Example. OH minus. Bracket albariri. Hydroxo. Cn minus. Cyanido. Okay. Cl minus. Next. Chlorido. Br minus. Bromido. I minus. You can write both iodo or iodido. I minus, you can write this as iodo or iodido. Okay. Next, NH2 minus amido. NH2 minus is called as what? Amido. NO3 minus nitrito or nitrito. NO3 minus nitrito. NO2 minus nitrito. CH3COO minus. What is it? Acetate. Okay. Some people even write it as aceto, but the original one is acetate. Is it clear? So you are learning a new system of naming which is according to the IUPAC. So all negative monodentate ligand. These are the common ones which we use. So they are called as what? Hydroxo, cyanido, chlorido, bromido, iodo or iodido, amido, nitrito, nitrito, and acetato or aceto. Clear? So all negative ligands end with O. Now write neutral ligands. B. Please write neutral ligands. Neutral ligands will only have what? Lone pair electron. The first neutral ligand is H2O. It is not called as water, but it is called as what? Aqua. It is called what? Aqua. Aqueous solution. So aqua. Okay? NH3. This NH3 is to be written as what? Ammonia. So we have derived it from there only. We write it as amine, but with the one extra M. Amine, how we write? A-M-I-N-E. This becomes what? A-M-M-I-N-E. Okay? NH3 is called as what? Amine. CO is called carbonyl. Fine? And NO. What is NO called as? Nitroso. N-I-T-R-O. Nitroso spelling NO. Nitro illa, nitroso. N-I-T-R-O-S-S-O. Nitroso. Alright. Positive unidentate ligand. Positive unidentate ligand. First one. It has, but it gives only one at a time. Okay, please write NO plus. Nitrosonium. It is what? Nitrosonium. Nitrosonium. Any positive ion? IUM. Ammonium, carbonium. So nitrosonium. NO2 plus. Nitromium. Is it clear what you have written? Negative ligands as O. Neutral ligands water as aqua. Amine, ammonia, NH2 as, NH3 as AMMINE. CO as carbonyl. And NO as nitroso. Now any positive ligand ends with what? IUM. So let us try naming one so that you get an idea. If I write K4 FeCN6, how many times it gets? 6 times. So this compound is called as what? Hexacyanido. Cyanide will give how many pair of electron? 1 pair of electron. So it is what ligand? Unidentate ligand. Is it clear? So it is called as what? Potassium hexacyanoferrate. How ferrate and all I teach. But this part clear? How we are using? Suppose I write CO NH3 whole 6 Cl3. So this will be called as what? Hexaamine. Here amine spelling will be what? AMMINE. Hexaamine. So always what is told? The number is written first. How many times it is repeated? Let us suppose I write NiCO4 tetracarbonyl. Gottaita ligands name ಮಾಡ್ತೀವಿ. Always how many times it is repeated. If I write AgNH3 twice, so diamine silver. So this is how you will always name. In a complex ion, first the ligand is named and then the metal atom. Naming the first rule. In a complex ion, first the ligand is named and then the metal atom of the ion. Clear? Alright. Bidentate ligand. Please write bidentate ligand. Definition here very. These are ligands which can donate two pair of electrons to the central metal atom or ion in a coordination compound. In a coordination compound. Okay, now write negative bidentate ligand. Negative bidentate ligand. The most common negative bidentate ligand is oxalato. See here, COO minus and COO minus. From here also it can attack the metal atom. From here also it can attack the metal atom. So it is what kind of a ligand? Bidentate ligand. Is it clear? This electron pair also can be donated. This also can be donated. So it is called as what ligand? Bidentate ligand. How do you represent? Oxalato. It is abbreviated as OH. It is what ligand? Bidentate ligand. Next very SO4 2 minus. It is called as what? Sulfato. SO4 2 minus. It is called as what? Sulfato. Now neutral bidentate ligand. Neutral bidentate ligand. Please tell example. This has been done now, Bhargav. Tell the example. It's going on, no? Yeah, okay, fine. Now, always understand what is this? What is this compound? Ethene. Remove one, double bond. So one valency becomes free here, one valency becomes free here. Correct? Now, what do I add here? NH2. What do I add here? NH2. What will be the name of this compound? One comma two? Di? Amidial banto. CONH2 idea. 1 comma 2. 1 comma 2. How many times amine? Diamino. Where is ethene? Ethane. तो मास पहनते समझ में नहीं आता. 1 comma 2 diamino ethane. Commonly called as what? Ethylene diamine. All state board students can write it as ethylene diamine. We still give marks. But CBSE board should not write ethylene diamine. They should write what? 1 comma 2 diamino ethane. Clear? You also should write 1 comma 2 diamino ethane. But पुराना भी अपना चलता है. Okay, ethylene diamine. How is it a bidentate ligand? The two lone pair electrons of nitrogen atom are donated to the metal atom, and hence it is what? A bidentate ligand. How it is abbreviated as? En. En is written as what? 1 comma 2 diaminoethane. Or you can write this also as, see, this can also be written ethane 1,2 diamine. Ethane 1,2 diamine. Now the beauty of naming bidentate ligands. If the bidentate ligand or any bidentate tridentate ligand, if the bidentate ligand is repeated twice, you write in front of it bis. If it is repeated twice, you write it as what? Bis. Bis ethane 1,2 diamine means what? The bidentate ligand is repeated twice. If the bidentate ligand is repeated thrice, it is tris. If it is repeated 4 times, huh? If it is repeated 4 times, tetris. Tetris ka ಸ್ವಲ್ಪ modify ಮಾಡ್ಬಿಡೋಣ. It is called tetrakis, but one is less. Okay, so it is pentakis. 6 times hexakis. Otherwise, dehydration will happen in body. So bis, tris, tetrakis, pentakis, hexakis. Clear? What did I teach? Negative bidentate ligand, oxalato and sulfato. I am telling you there are many, but in your syllabus this much is enough. Neutral bidentate ligand, ethylene diamine, also written as ethane 1,2 diamine, commonly abbreviated as EN. If the bidentate ligand is repeated twice, prefix added is bis. If it is repeated thrice, tris. If it is repeated 4 times, tetrakis. If it is repeated 5 times, pentakis. 6, hexakis. Pause it and write what all I have done. The second neutral example of bidentate ligand is written as DMG, dimethyl glyoxine. Biomolecule ಓದಿದ್ರೆ oxine ಗೊತ್ತಿರುತ್ತೆ. Okay, dimethyl oxine. It is called as what? DMG. Please write its formula. CH3, C, single bond C, CH3, double bond, NOH and NOH. Please write dimethyl glyoxine. How it links to the donor atom to the lone pair electron of the nitrogen atom. It is called as DMG or dimethyl glyoxine. Clear? So we studied negative unidentate ligand, positive unidentate ligand, neutral bidentate unidentate ligand. We studied negative bidentate ligand and neutral bidentate ligand. Positive, not much in your syllabus. We generally don't give you naming of them. Now write tridentate ligand. Tridentate ligand. Right? Definition purply. These are ligands which can donate three pair of electrons to the central metal atom or ion. To the central metal atom or ion. Okay, now write neutral tridentate ligand. Neutral tridentate ligand. First one is diIEN. It is called diethylene triamine. Diethylene triamine. Abbreviated as what? DIEN. Abbreviations are important because when you write a formula, they will not write the whole name. They will use DIEN. When you are writing ethane 1,2-diamine, they will use only EN. So you should be able to understand. Wherever abbreviations are required, I have taught you. Okay. Now understand what is diethylene triamine. What was this compound? This was what? Ethylene or ethene. What did I do? Put both sides diamine. So it becomes what? Ethylene diamine. Now what I do? I remove this and add what? Did you get my point? So now how many molecules of ethylene? 2. So it is diethylene. How many amine molecules? 3. So it is diethylene triamine. From 3 places it can ligate to the metal atom. So called as what ligand? Tridentate ligand. Is it clear what I did? What was my compound? CH2, CH2, NH2, NH2. From this I removed one H and added one molecule of CH2, CH2, NH2. So it becomes what? Diethylene triamine. 3 types nitrogen molecule and all the 3 lone pair electrons will be donated to the metal atom or ion and hence it forms 3 coordinate bonds, so called as what ligand? Tridentate ligand. Clear? If you understand ethylene diamine formation, this is very, very easy. Okay. Now write negative tridentate ligand. Negative मेरा हो गया. अब करो negative tridentate ligand. Aspartate. Hey, सुनिए aspartate. Vidisha knows auntie is going to catch now. What is aspartate? Huh? Aspartic acid. What is so famous about aspartic acid? Tell. It is there in green leafy vegetables. Where did I teach you? I didn't teach in aspartic acid. I taught you as amino acid. Acidic amino acid, aspartic acid. Basic amino acid, lysine. Aspartic amino acid has got 2 acidic group and 1 basic group. What does it show? Friday test. None of you have opened your book. It is already Wednesday. When do you read for Friday test? Friday morning. Which is not going to help. Aspartate or aspartic acid is what acid? It is an acidic amino acid. What is acidic amino acid? Which has got 2 COH group and 1 NH2 group. And nothing from proteins is removed. We have studied, so which is the acid which is present in Indian cottage cheese? Thyro? You said something. Tyrosine is the acid which is present in Indian. I don't know if you said pyrosine or what you said.
He said
Tyrosine, or you just said tyro. I don't know. So that is acid. Please go home, read amino acid. I have taught you separately some important amino acid. Glycine, optically inactive amino acid. Something has been taught. Kindly check. Okay. Now for aspartate, I know you will not remember. So the best thing is CH2, CH, COO minus, COO minus. I said it has 2 COOH group. It is an amino acid. So it will also contain what? NH2 group. So it is given NH2 group. So this has 1 from here, 1 from here, and 1 from here. So it is what ligand? Negative tridentate ligand. Please write. It is a negative tridentate ligand, aspartate. Now, tetradentate ligand. Tetradentate ligand. Definition barili. You only write now. These are ligands. These are ligands which can donate how many pair of electrons? 4 pair of electrons to the central metal atom or ion. Okay, now look here. En was what ligand? Bidentate ligand. Diene was what ligand? Tridentate ligand. Tetradentate ligand will become what? TRIEN. What is TRIEN? Triethylene. Triethylene tetraamine. Very good. Triethylene tetraamine. Triethylene tetraamine. Formula ಮಾಡ್ಕೊಂತೀರಾ ಹೇಳ್ಕೊಡ್ಬೇಕಾ ನೋಡಿ CH2 CH2 NH2 NH2 is what? Ethylene diamine. Remove one H, add CH2 CH2 NH2. This becomes what? Diethylene triamine. Now remove one H and add CH2 CH2 NH2. 1, 2, 3 and 4. So it is what ligand? Tetradentate ligand. We have to show like this, kindly show. Is it clear? We will not study its negative or positive ligand, only the neutral ligand, which is TRIEN, which is triethylene tetraamine. Now write pentadentate ligand. Pentadentate ligand. These are ligands which can donate 5 pair of electrons. These are ligands which can donate 5 pair of electrons to the central metal atom or ion. Name, please write neutral pentadentate ligand, ethylene diamine, triaceto, or you can write triacetato. Ethylene diamine, triacetato is an example of pentadentate ligand. Okay, now same, ethylene diamine forms my base. Correct? In here add ಮಾಡಬೇಕು ನಾನು acetate group. So CH2COO minus, CH2COO minus. Acetate is always CH3, but as it is forming a bond here, one H goes. So it becomes what? CH2COO minus. Here also one CH2COO minus and an H. Which all positions? One here, one here, one lone pair electron here, one the negative charge and one this negative charge. This is donated to the metal atom. So 1, 2, 3, 4, 5. Pentadentate again. I am not teaching the abbreviations because it is generally not used. Wherever it is needed, I will teach you the abbreviation. Here, now write the last hexadentate ligand. hexadentate ligand. Lot of times you have studied this EDTA titration to remove permanent hardness of water. EDTA titrations are done. What is EDTA? Hexadentate ligand. What is EDTA? Ethylene diamine tetraacetato. Correct. Ethylene diamine triacetato. Ethylene diamine tetraacetato is a hexadentate ligand. You can only write the formula, you don't require. If you have understood, it is CH2COO minus, CH2COO minus. Here also CH2COO and CH2COO minus 1, 2. Illa n martogidini last time nodi n martogidina I had written okay, sorry, 3, 4, 5, 6. So it is donated to the metal atom. It is called as what? Hexadentate ligand. It is called as EDTA. These are all depending on what? Denticity. If it donates one pair, monodentate or unidentate, 2 pairs, bidentate, 3 pairs, tridentate, 4 pairs, tetradentate, 5 pairs, pentadentate, and 6 pairs, hexadentate ligand. Now please write ambidentate ligand. Very, very important 2-mark question in board. What are ambidentate ligand? Ambidextrous andre enappa? Both hands. So what does ambidentate means? You will have 2 donor atoms. It can link even with this or with this. Like if I take an example of NO. N can also donate the electron, O can also donate the electron. So once it will link with N, once it will link with O. So it is called as what? Ambidentate ligand. Clear? Right. These are ligands which contain 2 or more ligating atoms, 2 or more ligating atoms in which, comma, one of the atom can donate electron pair to the central atom or ion at a time. Okay, so there are 2 donor atoms, but only one donor atom is linked to the metal atom at a time. So let us understand now NO2. Sorry, NO2. Okay, so let us suppose I have this as the structure of NO2. So the linkage is through what? Nitrogen atom. Now I can write this as ligating atom is what? Oxygen. This is called as what? Nitrito N. Because it is what? Linked to nitrogen atom. This is called as what? Nitrito O. So this is the example of what? Bidentate ligand. It has ambidentate ligand. It has 2 donor atoms, but it can link to the donor atom one at a time. So if it links through N, nitrito N. If it links through O, nitrito O. You know, the other example can be Cn minus and Nc minus. Cyanide and isocyanide. CNS minus thiocyanate. CNS minus thiocyanate. SCN minus isothiocyanate. Cyanide through nitrogen. Isocyanide through carbon. CNS through sulfur. SCN through nitrogen. These are all examples of what? Ambidentate ligand. We still have further more to go, but I think we meet on Saturday between 2 to 3 for a test on biomolecules. Thank you.